Is your plant water system costing countless thousands in excessive pumping, reducing the quality of your welds, and putting your expensive water-cooled equipment at risk? Hi, I'm Rusty Waters, Mark Niswanger's AI avatar. Mark is the Chief Technology Officer of Proteus Industries, a Silicon Valley technology firm specializing in the instrumentation and control of high-tech liquid cooling. As the inventor of the world's most advanced water management devices for robotic resistance welding, Mark has decades of experience with water systems in the body shops of the world's leading car makers. So let's take a look at some of the pitfalls Mark has encountered in automotive plants around the world and how you can easily avoid them. Many water systems use vertical pipe drops from overhead water mains to supply water hips that distribute water to robotic welding cells. Keeping these drops completely straight will minimize the resistance to flow and reduce the load on your pumps. 90-degree elbows are among the biggest reasons your pumps may be working too hard. Avoid them at all cost. If you must move laterally, do it with 45-degree elbows to minimize turbulence. Turbulence adds extra load on your pumps, and the sharper the turn, the greater the load. High water velocities also increase flow resistance, so keep water moving under 6 feet per second. Here's a corresponding chart of flow capacities for various pipe sizes. Stay well below these limits to keep water flowing efficiently with minimal pumping effort. But in any case, don't size water drops and hips under 2 inches. And don't overlook the impact other components like strainers and valves can have. The inside diameters are often smaller than the corresponding pipe size, restricting water flow. In these cases, consider oversizing components to ease the load on your pumps. Also, many automakers find additional benefit in sizing water return pipes larger than the supply to reduce the return water back pressure. Water hammering can occur when operating shutoff valves within the cells, causing a pressure shock wave that readily propagates through water hips from cell to cell. This can cause false alarms from flow measurement devices used to detect cap loss, resulting in costly production delays. Among the ways to minimize water hammering are the use of angled seat valves to reduce shock and larger diameter water hips to better absorb shock waves. Water hammer arresters can be placed on water hips, or even better, at each welding cell to absorb shock waves. Here's a common configuration that makes it harder to pump water to welding cells. What's the problem? Again, pipe elbows are the culprit. In even the simplest systems, they add up to significantly impede water flow. Compounded over hundreds of cells, it's no wonder when water flows are low, pressure's high, and pumps overtaxed. You wouldn't use straight pipe and elbows on your engine, right? Of course not. Just as smooth exhaust flow provides maximum power to the wheels, smooth water flow provides the greatest power transfer from your pumps. Use continuous flexible hose, 3/4 inch or larger, with minimal fittings and sweeping bends instead of straight pipe and elbows. The inside diameter of fittings is smaller than the hose, so they also add flow resistance. Check spec sheets to get the biggest available. Some automakers even upsize hoses to avoid fitting restrictions. And again, consider oversizing components like valves and strainers if needed to avoid smaller inside diameters. Using a pipe T when branching a water line is a common mistake. Just as with elbows, the abrupt change of direction creates turbulence that adds flow resistance. Use pipe Ys instead of Ts when branching to other equipment, such as the weld controller. And don't connect branches directly to the inlet of flow measurement devices, or for that matter, any component that disrupts smooth flow. They may impact the measurement accuracy. Add a straight nipple on the sensor inlet to improve measurement accuracy. Even hose fittings can affect accuracy. Add a nipple if their inside diameter is smaller than the sensor diameter, which for the weld saver is 15 millimeters. And don't use pipe Ts when branching to double hoses for the robot either. Use pipe Ys here too. The EVAC coolant delivery and retraction valve converts water pumping power into suction force. It needs 6 to 8 gallons of water per minute, depending on the pressure conditions. This may be higher than the flow to a steel welding gun. So it becomes particularly important to follow the previous guidelines to assure these higher EVAC flows. And as you can see from this chart, high water supply pressure requires higher EVAC flow to generate suction. This is where the previous advice on oversizing the water return lines becomes particularly relevant to reduce the return back pressure, which in turn reduces the supply pressure. Under certain conditions, the EVAC may allow water to backflow through the robot return line and leak from a removed welding cap. This can happen when there's insufficient EVAC flow or the pumping system is shut down and residual water in the system can gravity flow through the EVAC. If these are potential issues in your application, a non-return valve can be placed on the return line to prevent backflow. Some automakers install a flow-regulating device, sometimes called a flow setter, on the water supply to each cell to balance the water flow to all the welding cells on a production line. While this can be good to keep the flow the same for each cell, it also prevents the EVAC from getting enough flow. Move the flow setter to the welding gun supply line instead to balance robot flow without restricting EVAC flow. If struggling to get enough flow to the EVAC, consider moving the water connections for the cell directly to the overhead water mains instead of a water hip to deliver completely unrestricted flow. To get even more water to the EVAC, you can move the branches for a weld controller to the lower weld saver connections, so it only gets water when the EVAC is delivering flow to the gun. Or you can move the weld controller completely away from the EVAC water supply to increase the EVAC flow, connecting instead directly to a water hip or the overhead mains. And on a final note, you don't want to have your robot hoses flattened, so keep in mind that the continuous suction generated by the EVAC can collapse hoses if left on for an extended period, especially overnight. Take steps to prevent the EVAC from shutting off gun flow any longer than necessary to change caps. Do you know that reducing a pump's speed by 20% saves 50% in energy consumption? This makes it well worth the initial cost and effort to achieve smooth flow with minimal restriction. Overall supply and return pressures of 60 and 30 psi respectively, with 4 gallons per minute of flow to each cell, is a good measure of success, and I'm looking forward to seeing your results. And if you're using the Weld Saver, thanks for allowing Proteus to share in your success. We're committed to keeping the Weld Saver your best choice in water system management. Check out my presentation on setting up the Weld Saver to perform best for your specific requirements. That's all for now. See you next time.